So good afternoon and good day for everyone. So this is the fourth day of BioMedVis Spring School, and I think you are probably already exhausted, but we are still having a lot of exciting program today. So let me begin with introducing our first speaker. Our first speaker is Silvia Miksch, and Silvia is a professor and the head of the research division Video Analytics at the Institute of Video Computing and Human-Centered Technology at TU Vienna. And Silvia and her research group have investigated several intelligence-based video analytics approaches, especially having a strong focus on temporal data visualization. So by the way, if you own the book, Visualization of Time-Oriented Data, maybe it's a good time for you to ask her to give you a signature. So she also initialized the BioMedVis wiki, which I also use a lot in my teaching, which I really appreciate very much. And she also served a lot of served as co-chair in many conferences in visualization, including IEEE, Eurovis, and also serve as editorial board of several journals. And thank you, Silvia, for accepting our invitation, and the floor is yours. You are muted.
Sorry, now you can hear me, right?
Yes, perfect.
Sorry, I was muted. Thank you for these nice words. Now I'm really a little bit more nervous to give my presentation in front of my laptop and talk about my research. Okay, thank you, and thank you for the invitation. It's really nice. Okay, what I will talk is about visual analytics for time-varying data. And what I plan to talk is, first, I will give you a short motivation, contextualization. What is the understanding of visual analytics? What is time and time-oriented? What is events? What are data user tasks? And what kind of information we need to tackle if we are dealing with visual analytics for time-varying data. And then I will show you a couple of examples and insights, and I will end up with some challenges, opportunities, and some final remarks. Okay, let's first think about the motivation and contextualization, what we do in the hospitals and what we do with time-varying data. One of my favorite examples is always dealing with newborn infants, and there you see the hospital, and then you see the small baby, and then you see the different devices that the baby was connected to, and there is a lot of heterogeneous, multidimensional data available. And if you think more carefully which kind of information you should tackle, then you start first with data. What kind of data? You have patient data, you have clinical guidelines, which are kind of procedures, how to treat the patient correctly, and then you have different kind of resources. And the other thing, you have users. This can be different kind of, in the medical field, it can be physicians, nurses, or the patient themselves. And then you have particular organizational issues which you need to tackle. And the third dimension is the tasks, different actions you need to take according, for example, the clinical guidelines to heal a patient, and particular other processes what you want to tackle. This data user task is the main components which we need to incorporate in our visual analytics approaches or solutions. But this is not the only thing. These different data user tasks are changing over time. And this is particular the challenge what we want to address with our visual analytics solution, data user tasks, and how they change over time. One appropriate way to handle this is with visual analytics approaches, and visual analytics is the science of analytical reasoning facilitated by interactive visual interfaces, and was introduced by Thomas and Cook 2005. And the basic idea is that you have visualization and interactions, computation and mining, human perception and cognitions, and these three components are intertwined. Yeah? and you want to support the process of insights, gaining insights. And there is also a European perspective of visual analytics, where I also participated in 2010. It's solving problems with visual analytics. As I told you, the process of visual analytics, the process to gaining insight or to gaining knowledge is, this is the process developed by Daniel Keim in his group. You start with the data, you have one path, you go over the visualization to gain knowledge, or you take the other path, data, doing mining methods, then using, coming up with models and gaining knowledge. And the critical part is really that you use different kinds, or the interesting part, sorry, is to use the visual analytics, use visualization for model building to get better models, and the other way around to use the models to get better visualizations. And this is not a single step process. You have always this feedback and start again. And then you have different kind of interactions, transformations. I don't go in detail. I just want to contextualize what we are doing. This is not a one-step approach. It's a dynamic approach, and it lives from interaction and dynamic views. Okay, we have done a couple of these things in the past. Partly of things in the past. Different kind of approaches according to this data user task model. And I will tell you now a couple of examples how we try to incorporate data user tasks and try to incorporate the spirit of the visual analytics process. Okay, I come with my examples. First, I'm referring to a nice book chapter, what we already wrote 2013, where we also try to categorize the different kind of visualization approaches according to a single user or the patient cohort. And it's just a reference if you want to learn more about the different approaches. This is a good starting point. Okay. Let's go to my first example. My first example was the PhD thesis, or part of the PhD thesis of Teresa Gschwandner. It was Care Cruiser. It's an interactive exploration of the effects of therapeutic actions on a patient condition. And what does this mean? You have the different users. The users are medical experts, physicians. The data, you have patient data, and you have treatment plans. And the data is multivariate and abstract, and the time is linear instances. And the task, what you want to achieve, is explore the effects of clinical actions on a patient condition. And what you see in this visualization here shortly is, here you have the clinical here you have an overview about the clinical guideline, and here you have the concrete actions. And here you see the different kind of time series. I have a better picture in my next slide. We start here as again the guideline, the knowledge of the guideline encoded in computer interpreted guidelines. Then you have the action plan here, and then you have different kind of time series here on the top, and then down here you have different kind of actions. And the diamonds represent when you have to do an action, and it represents when it's in this part here, it is included in the guideline. If it's somewhere outside, it's not included in the guideline. And here you have different kind of interactions because you wanted to assess the therapeutic actions according to different kind of matrices, like distance relative to the value and to the slope. Let's look at this in a little bit more careful, and let's see this system in action. I hope you see this. First you select any action, then you choose these actions and see what's going on here. Then you try to synchronize the different kind of time series, and because you wanted to compare different kind of time series, then you want to see how the slope is actually. It means how fast you are in a good situation. Then you can select particular with particular values, and then you can use the lens to see what's going on, what's good and what is not so good. And then now you want to compare the different actions. You have here one actions and here the other actions. And then you can see in this lens that here is quite stable, here is also quite stable, here is a little bit oscillating, and here is stable again. And with these different kind of features, you can compare time series interactively according to some knowledge that is behind. The knowledge is encoded in the clinical guidelines. Okay, this was my first approach. My second approach is done by Paulo Frederico, GNIUS. It's a knowledge assistance electronic health record visualization of patient cohorts. And here the important thing is that you're dealing with patient cohorts. And this was done in collaboration with other people. What are our users and data and tasks again? Our users are again medical experts and researchers and physicians researchers. The data is again patient data, treatment plans, and multivariate abstract data, which is linear and is instances. And the task what you want to do is you want to detect any patterns. And I will explain you how you interact with the system again. Here you have again our guideline and our actions. It's the other way around. I don't know why, but it's the other way around here. Here is the overview about the guideline, and here's the actions. Then you have the knowledge-based temporal data abstraction of the cohort, because you wanted to see many patients, and each line in this heat map here, each line is a patient, and you categorize it according to high values and low values. This is the second one. The third one is stream box plots, that you use box plots and put them together to see how the deviation looks like. And the last point here is the different treatment plans and how and the compliance to the different treatment action recommended in the clinical guidelines. And this means here, if it's in this hole, then it's obey to the stuff, and the color coding and the size tells you according how often this treatment was applied for the particular patient cohort. Then you can have different kind of interactions and navigations. And the different kind of interactions as a navigation is the first is a lens, where you can order them according to the severity of the disease. Yeah? The next one is that you can have such a focus and context techniques that you can select. I told you that this is the patient cohort. Each line is one patient, and then you can select one patient, and the patient is in the focus, and the rest is in the context. The cohort is in the context, and you can also see how this patient behaves in the different other views. For example, here you see the orange points. This is the particular patient in the stream box plot, and here you see the different kind of action the patient had been done. Okay. I don't only want to present my stuff. I also wanted to give you a little bit of clue about what's going on in what other people are doing in the medical field. And particular, what I found interesting is if you're dealing with temporal event sequences. And this is approach what is done in the human-computer interaction group, which was led by Catherine Blasson. And it was done mainly by Van Du and Sana Malik, and of course Ben Schneiderman and Adam Perra. Just to ground you a little bit what the human-computer interaction group has done, they have quite a long history in this field. The first thing what they did was lifelines, where you have the different, where you have the here you have the different observations, and each line tells you one observation, and you can open and close these facets. This is done particular for single patients. Then they enhance this approach, lifelines 2, to aggregate this for a patient cohorts or a multiple patient. Here you see the individual records. Then you see some aggregation value here down here and other information here on the left. The next thing what they did is the life flow, which was again explaining particular sequences here and coordinating the particular sequences, but it can only handle event data. And I want to focus, tell you how event flow is working. The event flow is working if you have a lot of this event data here. It got such a kind of confetti. It's quite hard to read and hard to see. And they wanted to come up with a more nicer visualization. And I will explain you how this event sequence are derived in the next slides. I just want to give you the clue what is the precondition and what they are aiming for doing. And the basic idea is it's particular focusing on analyzing temporal event data, visualizing them, searching for particular patterns, and giving also summarization about the sequences and their timing, relevance, and find anomalies, and also some data transformation to real useful patterns. The main message is they want to do it for pattern finding, and they wanted to select patients or cohorts of interest. How is this working? Just to give you a clue. If you have this structure of a patient, you have here time point based observation, and here you have some events. What you do is you match for every patient to the time X. This is for one patient. And the next thing is that you have here multiple patients, and now you want to find some grouping. That you first order them on the event basis, then you merge them together. As the next step, you look at the frequency, how often they appear, order them according to how often they appear, and merge them again. And this process you are repeating and repeating and repeating and repeating. Sorry, there is a number of records, there is a time, and then you come up with this event flow where you see, where you see here, here you see the details, what you have observed. Here you see the aggregated events, and here you can get some additional information. Good. Just now some glimpse what other approaches could be done, or other visualization could be done. In short, what we did with Gravi++ is that you have here patients, and then you have different kind of measurements or different kind of observations, questionnaires in this sense, and then you use the spring metaphor to group them together according to the different answers of the patient. Another nice stuff is, for example, what is done in cooperation with Heidi Schumann and colleagues, is the activity recognition using visual analytics, where you have to use the analysts, you have again activity sequences, you have multivariate abstract data, linear and instance time, and you want to compare patterns and detect temporal stuff. And what is the basic idea? You're observing a person. You have different kind of sensor data, and this different kind of sensor data should correspond to different kind of activities, multivariate, abstract, time series, as I told you. And then you could abstract, this is a sequence of cooking, this is a sequence of eating, and this is a sequence of washing. Sorry. And then we come up with such different kind of visualization. And the basic idea was that we want to fine-tune the different parameters, how would be a good fit for the particular purposes. And here you see the different kind of parameters, and here you can see different kind of heat maps, which are showing you different kind of configurations. Okay, of course we have done something for COVID. Everybody done something with COVID. We did this also with we did Roger Leiter, one of my colleagues, co-workers did, where we observed the developing on the COVID and combined them with some knowledge about the different activities. Okay, my last approach is a recent research, what I did together with Lisa Müller, who is a co-worker in my team, and where we want to use to do knowledge assistant visual analytics. The users are medical researchers, again, multivariate abstract data, linear and time is linear, and we want to explore, assess different pattern, associate and compare. And what we did is a visualization. The data are questionnaires about eye diseases of different patients. And what we did, we developed here a nice interactive tool where you see here 2 different questionnaires. One line is again one patient that we had before. We had encoding the different answers to the questionnaires in the color codes. Don't ask me the question why red and green. We had the different coloring, but the medical expert wanted to have red and green. I'm aware that this is not a good solution, but we did it. What you have here is a parallel sets. What it was developed by Bendix, Kurosawa, and Hauser quite a long time ago, 2005, if I corrected correctly. And you can use these parallel sets to select particular elements to order them according to the gender, the different treatment, or the different severity of the disease and the age. And then you can compare them. And then you have here additional other views. And a very nice view is, for example, that you have them connected to each other, that you can, for example, compare how the females and how the males are answering according to the different questionnaires, where they with these questionnaires, you get the feeling how good the patient is how is his feeling, how is his health condition concerning his eye disease. Third remark, I put it in, there was also a best vast paper 2020, which was also dealing with visual analytics in search of patient 0, visual analytics of pathological transmission of pathways in hospitals. And I recommend you to read this paper. I can't explain it in my 20 minutes because I'm still on mobile. I end with my challenging what should be done in visual analytics in healthcare. The first challenge is to deal with scale and complexity of time and space-oriented data, intertwining the patient condition and the processes, the treatment more appropriately. Scalability analysis of single patient to patient cohorts is not so easy. Dealing with the data and the data quality uncertainty is often not taken seriously. You have to do more thinking about the different kind of interactions, the user interfaces and the roles, and evaluation and guidance. I thank all the funding agency and all the persons who worked with me and my team. Thank you.
Thank you very much, Silvia. Let me check to see myself. Okay, good. So let me check. Oh, okay. We have a questions from Harvey.
Sorry, I didn't read it. Of course I didn't.
No, I'm going to read it for you, so you don't need to.
Sorry.
So he mentioned that yesterday in Paco was asking an interesting question of good reference article of these solution that were worked out with the help of wavelets. I would not be surprised if, if Silvia, you are the right expert to provide the most relevant pointers. Okay, would be great. So I'm not so sure. I think it's a statement or the questions.
I didn't understand the question.
Yeah. Okay, maybe Paco want to clarify this. So actually, I have a question. So you have been working with a lot of experts, probably with a lot of different teams. And how do you manage to coordinate with domain experts, especially they probably have a different goal as a visualization research goal?
Okay, this is a very, very challenging thing, yeah? Working in interdisciplinary teams and coordinating the different persons. And particularly with physicians and healthcare persons, yeah? Because they have totally different visions, yeah? And totally different time schedules. Yeah? And they usually always think computer science visualization is easy, and we are doing the high scientific stuff. Yeah? It takes a while that you work close to each other, yeah? And understand each other, but you could support. You need to really speak their language a little bit, then it's easier. And the other thing what I observed is concerning time. Physicians are very busy during the day, but if they have a night shift, they have a lot of more time. And I spent, when I was younger, a lot of nights in the hospital to work with the domain experts, and then they had really time to explain everything.
Great, thanks a lot. Now Paco has rephrased his questions. So he's asking, do you know any real life usage of wavelets in visual analysis, maybe related to BioMedVis?
Real life stuff. I don't understand the questions really. Can you repeat it again?
He was asking, do you know any real life usage of wavelets in visual analysis, maybe related to BioMedVis in wavelets?
I don't know it by heart, I'm sorry. I have to.
Okay, maybe we can do it.
I can check it out. I don't know really.
So I think it's this wave-like leaf representation. Okay, maybe we take it a bit offline. Do we have other further questions? Or maybe Paco, if you could give us an example at some point, I can share it to Silvia. Okay, so the repeat questions here. So maybe I will follow up the previous question for myself because I'm really trying hard to get this collaboration with domain expert, and this is really not easy, especially if I'm located in a different country speaking different language, and it probably require kind of long-term relationship to step by step build up the relationship between the collaborators. And do you have could you give us some time frame as experience how long it will take until the whole collaboration can be settled up?
Wow, this is a very difficult question. I never looked how much it takes. Yeah.
I mean, but from your experience, I think that's already very helpful for most.
Yeah, for me, I was thinking my first medical collaboration was the person who was dealing in neonates, newborn infants, and it took half a year until we could understand each other. Mm-hmm. And the other one, I would say half a year.
Half a year, that's all. That is actually expecting short for me. I don't know.
You know, I have also to confess, I collaborated with them always for many, many years. Yeah? Mm-hmm. And then my main person was always my contact person. And this main person was connecting different people together. Yeah? And therefore, it was quite easier because it wasn't he. Yeah? He was the communicator between the different other people. Mm-hmm. This makes the life easier if you have one contact person and then connect.
Okay, so we have to find the key person, this hub person in the
society. Like a network, the main.
Yeah, the hub. The hub guy with a higher degree. Yes, cool. So Renata was asking, can you maybe elaborate also about other scalability challenges, except one for one-many patient extensions?
Sorry, the internet connection is a little bad. I didn't. Okay. Renata was asking about scalability.
Other scalability challenge.
Other scalability challenge. I mean, okay. Sorry. I should have opened Discord in parallel. Sorry, I didn't do this.
Yes.
Okay, yeah, the scalability. You know, the scalability issue, one is single and code. I had this already, this is true. The other scalability issues is the visual scalability. If you have multivariate data, how to really visualize this multivariate data and how to visualize the different dimensions, and how to really handle the different kind of knowledge which is in the data, in the electronic health record and a different information and knowledge with this in the clinical guidelines, yeah, how to handle them and visualize them. It's in the sense of, if you want to use a lot of domain knowledge, or how to use this domain knowledge to solve the scalability issue. On the other hand, how to tackle this huge knowledge.
Great. Thank you very much. I think we are running out of time. So there are a few questions that we need to clarify. I would invite you, Silvia, later to join this call and to have a discussion with the audience there. So thank you very much. And we will see you on Discord later.